So,
What is the
all right. So this is like a network. The starting data, like this is like a famous data set that's used in a lot of papers.
okay?
Um, and this data set is basically saying, hey, there's these 15 or so women, and then these women go to these events or these classes or something.
Okay.
So and we have data about which events these women go to every week,
Okay.
and then therefore we can tell the social graph of this group of women, uh, based on which of the women go to the same events, basically.
Okay.
And
Got it.
then based on that, so the way they did it, there's multiple ways you can sort of color this information, but
Okay.
the way that this author did it, and let me read this author's name. Valdez Krebs, that's the author, and he's saying, um, a woman X is connected to woman Y if they both attended a certain event. Um, but they can give different strengths to that connection. So, for example, if women X and women Y, they both have two events in common, then
Uh,
they have a stronger strength than if they only have one event in common.
okay. That makes sense.
So what he did is, like, he starts with like a really big strength. He starts with strength of 4, the strength of 4 graph. So he's only going to show the women that are connected based on that they go to 4 of the same events together. So
Right.
if they did that, you get this small graph here
Uh-huh.
that shows there's 4 women who go to 4 same events together.
Okay.
There are 4 events where if you go there, you will see all 4 of these women every time.
Uh,
And
okay.
then there's a separate group of 4 women. I mean, 3 women that go to a distinct, like some other 4 events, but are not
Mhm.
connected with these 4.
Right.
There's 3 other women that are very strongly connected together based on what events they go to.
Right.
So this one over here is the strength 4 graph. And then if we reduce it down to if you allow this less strength, like strength 3, you'll get more women showing up in the graph like this.
Okay.
But in this data set, you can still see there's 2 distinct groups of women that are
Uh,
really connected together, but there's no overlap between the groups. And then if you
gotcha.
add even more, allow the weaker strength in.
Mhm.
It's not this one. Sorry. If you then allow more weaker strength in, you get at the end you get this graph. If you allow
Okay.
strength 1, you can see there's 2 really closely connected groups, but there's some
Mhm.
other people that are sort of not as connected to the middle of either of the graphs.
Mhm.
So
Interesting.
um, I think that could be potentially very interesting for applying that concept to Git repositories.
Okay.
If you, instead of using the event, you use a file in the repository. Like,
Uh,
2 people are connected if they both edited this file in the
oh,
repository,
okay.
and you use that to build up a social graph. You might get some interesting information out of that.
Mm-hmm. Interesting. Well, do you think like the social network software use this kind of stuff to calculate like how people should be connected?
They probably do. Yeah, they have so much information. I'm sure they've looked at this. Yeah, like if you're Facebook and you're working, you're working on the Facebook team that's doing data analytics. I'm sure they all know this kind of research. So I think that could potentially be interesting for visualizing GitHub history, but there could be other ideas that this is applicable for.
Do you think this can be used to see whether the certain modules are coupled to each other?
Oh yeah. Yes. That's another thing is because there's also a visualization not for the women but for the events.
Okay.
So this is a visualization for the events, and it kind of tells you how do I explain this? The events that have these stronger lines connecting them are the ones that are kind of have a lot of strongly connected people to them, basically. So maybe you can think of them. So like event A is connected to event B if they were both attended by the same woman, C. So it's like a two, like the line. If there's a line between two events, the line gets stronger the more people there are that go to both of the events.
Okay.
So this strong line means there's more women, let's say 10. There's 10 women that go to both of these two events.
That makes sense.
So I guess what you can say about that is and they kind of strategically arrange these nodes so that the strong links are sort of laid out in the middle.
That is true. Yes.
And I don't know if a person did that or an algorithm did that, but they just arranged it that way. So you can sort of see, there's this, the around the center is where the important events are. So based on that, you can think about, if I want to be influential, if I want to influence the women in some way with like a message, or I want to sell a product to them. I guess usually it's like that. I have this social network app. I want these women to use or something, but it could be any kind of thing, or maybe it's like a political message. You want them to vote for a certain political candidate, whatever it is. Then you'll know I want to infiltrate them by going through the strong links in the graph.
Gotcha.
Yeah. So that's interesting. So maybe like you could do the same thing with the code repository, where like you can see where the strong links are. The strong links are surrounding some set of files that get sort of heavily changed, I think. So you can kind of see the set of files that are important, at least in this way of looking at things.
That makes sense.
I think for new people going into a code base, this can be useful to just know what files are more worthwhile to look at for them, maybe.
Yeah.
Or what people to ask if they have questions. Yeah, okay. And the last one I want to show is there's a couple of guys, Martin Wattenberg and Fernanda Viegas. So they came up with a way of visualizing articles in Wikipedia. So this is a visualization of the article chocolate on
What?
Wikipedia.
Okay.
And you can see at the top, you can see these tick marks here.
Uh-huh.
Or you can also see these straight lines in the background. So each straight line is one version of the
Okay.
article.
Okay.
So somebody has edited between this straight line and this straight line. But the
Okay.
horizontal line or the diagonal lines in some cases is telling you for each word, I believe, in the article, it's saying this diagonal says this word from the previous version moved up to this location in the article in the next version.
Okay.
So like that word survive the edit.
Okay.
When there's a diagonal, the word moved from here, and then in the next version it moved down here, and then in the next version it moved down here, and so forth. And
Mhm.
the color is based on the author of that word, the person
Oh,
who. So at the beginning, it was just one author, and
uh-huh.
it's this light pink person.
Uh-huh.
And then in the next edit is still mostly light pink, but there's this a little bit of green up here. So there's a second
Uh-huh.
author that wrote a little bit on top, but some words got shifted up. That means some of the words over here probably got deleted, and
Mhm.
maybe the green author decided to rewrite the beginning chunk, and and
Mhm.
and then delete a bunch of or just shortened it. I like this. You can see the movement of the content over time. And if you're wondering what this zigzag stuff is,
Y-
that is
Yeah.
that is a edit war where
Okay.
so clearly this content stays the same starting from here, but it just moved up and down,
Uh-huh.
and that's because there's not a section here. Somebody wanted to add this section, but then another person decided to delete it immediately, and then the first person wanted to add it again, and then they wanted to delete it again.
That is funny. I think GitHub should have this too, so that I can see who messed up the code.
Yeah. Yeah. So this is like a typical edit war. It's with this going back and forth, back and forth. And then yeah, it's cool that you can see the authorship of the lines, I think. Let's look at maybe another example. Okay, so can you tell me what these black bars are here? Why is it dark for two for two consecutive lines?
Wait, does that mean stuff get deleted?
Yeah, yeah. Everything got deleted.
Oh man.
And on Wikipedia, that's like a common thing. It's called vandalism. Like somebody just came in and decided to delete the article.
Wait, so is there like people reviewing this kind of stuff or not?
Yeah, on Wikipedia, they actually have a lot of people that are monitoring. So it's okay if somebody just vandalized the site. People will notice and then just put it back,
Okay.
which is what happened.
That's very interesting.
Yeah, so you can see this is vandalism, and this is, I don't know, this could be just like a edit, like maybe a big section was deleted. Yeah, here a big section was deleted too, like probably from here to here. What I like about this is you can see the movement of the text, which
Uh-huh.
which with the diff tool that we use, we don't see the movement necessarily. Oh, here, like you can see some text is going down and some text is going up here. So
Mhm.
if text swapped in position, like sometimes you just say, hey, this function in the bottom, I would like to move it up to the top.
Mhm.
But if you do a diff with git, it'll show up as one deletion and one addition. to the code.
Right. Uh-huh.
So, but with this algorithm, it actually shows that as a movement.
Well, if you changed a lot of stuff in the function, like how would that work? You not only moved it, but you also changed it.
Oh, right. In a lot of cases, this algorithm will also show as a movement.
Uh-huh.
This algorithm is interesting in of itself. It's called the Paul-Hackl diff algorithm. There's also the Myers diff algorithm. And I just learned about the Paul-Hackl one, and there are things about it that I really like. But perhaps we don't have time to go over it right now. But one of the things I really like is just this being able to track movement. I think this can also really be useful for reversion controlled projects to see a visualization like this for a file.
Yeah.
You can see where refactors got done. Like this is clearly a refactor over here.
Yeah.
Now this is not for code, but for article. But the same concept applies. Like they did a big refactoring over here. Well, actually, no. They just at the end they just reverted back. Somebody tried to do a refactor, but they abandoned it. It is what happened. Yeah, that's what happened here. Here, there's this temporary edit going on here. I don't know, like somebody decided to replace three huge sections with something entirely different, maybe. And then they reverted it back.
Yeah. Well, somebody deleted all the stuff and then replaced and then delete again and then reverted. Interesting.
But it's not a deletion because these movements are going downwards.
Oh, that is true. Well, but the blue chunk stopped in the middle. Like on the black spot, like where there it was black. So on the left, there was like the blue, a big chunk of blue. Yeah, that. And then it got removed for a while.
Oh yeah, this cyan part.
Yeah.
That got removed, but it kind of came back over here. But then you kind of lose the linkage once that happens.
Yeah. I think it's pretty interesting to look at. Yeah.
Yeah, and another thing I thought about is like, well, this is only for one file. Can we have something like this for the project level? Can we zoom out one level and see a similar visualization? I think you probably can if you take the output of the ls command line and you tell ls to print out the files recursively. And then you just diff the output of ls. You can probably get a similar view of the whole project.
So is it at the file level to see like how many files, or are you talking about getting everything in terms of content in a project?
I thought about both, but yeah, but probably the one that makes more sense is just have the file listing of the whole project be the content, and then diff that at the next versus the next version of all of that.
Okay.
Yeah.
That makes sense.
I think this could be a very cool tool. I'm kind of motivated to do something about this.